Alright, in this video we are looking at solving equations when variables are on both sides of the equal sign. So the steps that you want to write down at the beginning before we actually start solving anything. First step is to use the distributive property, and this is in a different color because it will be in tomorrow's video. Step 2 that we're going to start with today is combining like terms on each side. Step 3 is to move the variables to one side of the equation, and just so you know, I usually prefer the left side, but it really doesn't matter which side you move it to. Step 4 is to move the constants to the opposite side of the equation. So if I move the variables to the left, I'll want my constants on the right. And finally, step 5 is to isolate the variable. Isolate means get it by itself. So in order to do steps 3, 4, and 5, we'll be using inverse operations. So opposite of add is subtract, or opposite of subtract is add. So you'll be using those for steps 3 and 4. And then to isolate the variable, for step 5, we'll be doing the opposite of multiply is divide, and the opposite of divide is multiply. One thing I forgot to mention is that steps 3 and 4, you can technically do these in either order. You could move all the constants first before the variables is fine, but if you have these notes, it's okay to still follow these step by step if you're struggling with the process. So the first thing I want to do here is I'm going to color code. So our like terms that we were talking about here, we have 6K and 3K. Notice that I'm also underlining the plus sign in front of 3K because it's positive. 6K is also positive because it doesn't have a symbol in front of it stating that it's negative. And then again we have a positive 1. Notice I'm using a different color. We have a positive 1 and a positive 16. Those I'm color coding because those are our constants and those are like terms. Okay, so our like terms are not on the same side as each other, so I'm going to have to start with step 3. I'm going to start by moving the variables to one side of the equation, and as I mentioned earlier, you'll use inverse operations. So the opposite of adding is subtracting. And notice I'm trying to get rid of it here to move it to the left side, because again, that's the way I prefer. You could have just as easily done subtract 6K from both sides, and you would have ended up with a negative 3K on this side, but these are going to cancel this time, and we end up with a positive 3K on this side. And so now I'm just going to bring down the rest of the problem. So we'll bring down our plus 1 that we haven't used yet, our equal sign, and we'll bring down our positive 16. And again, these cancel out, so I'm not bringing anything down here. And the next step, now I still have these two like terms. I need to combine, but this is step 4 because I have to move our positive 1 to the other side away from our variables. So we will subtract 1, again, inverse operations. And these will cancel out. So I have 15 on this side. And again, I'm just going to bring down this 3K. You can bring it directly down underneath so you remember where you got it from, or you can bring it closer to the equal sign. All right, and my final step, step 5, I'm going to isolate the variable. So when I say isolate, it means get it by itself. So this is read as 3 times K. So we said before the opposite of multiply is to divide, so I'm going to divide by 3. If it was a negative 3, I would be dividing by a negative 3. Alright, so now this is 3 divided by 3. It cancels out, but it becomes a 1, and we don't usually see that one. There's like an invisible one there. So now K is by itself. And we have the answer of 5. So we have K equals 5 as our answer. A way to check that if you wanted to add step 6 is to substitute in the original problem to check your answer. I'm sorry for my sloppy writing. But if you want to add this to the bottom of your list underneath number 5, you can. So again, if we plug this in, plug in the 5 here, we get 6 times 5 plus 1. So that would be 30 plus 1 is 31. And then we'd be doing 3 times 5 plus our 16. 3 times 5 is 15 plus 16 would be a total of 31 as well. So we'd have 31 equals 31, which is true. So then that means our 5 is correct. All right, in our next example, again, we see no parentheses stating that we need to use the distributive property. So again, that'll be in tomorrow's video. First, we'll start out with combining the like terms. So again, I'm going to kind of color code these. So we have our constant, a positive 7, positive 5, and positive 4. And we have our variables, positive 4x, negative 6x. Again, it's negative because it has that subtraction sign in front of it, so it kind of belongs to that term. The same with negative 4x. Again, it has a minus sign in front of it, so it kind of belongs with that term. All right, so if we put those together and combine them on the same side, so we have 2 variables on this side, of positive 4x, negative 6x. So that would be a total, we have a negative 2x, and then we'll bring down our plus 7. On this side we can see we have 2 constants, so we'll just put those together to help simplify. So we have 5 and a positive 5 and a positive 4, that's a total of 9. And then we'll bring down our negative 4x. All right, so now that we combine all the like terms, so again, you can see we don't have any more like terms on this side of the equation or on this side of the equation. So this is where we come into step 3, where we're going to start having to move things around. Again, you could move the constants or the variables first, whichever order you prefer. So I'm going to start by, instead of subtracting 4x, I'm going to use inverse operations and add 4x to both sides. So these would cancel. And notice I'm lining up x's with x's, or variables with variables, because this is what I'm adding it to. Because I can combine these because they're like terms. So we have negative 2 and a positive 4. That's a total of 2. And again, I'm just going to bring down the rest of the equation that we haven't used yet. In this next step, so now I have my variables on the left side. I need to move any constants away from it to the right side by using inverse operations. So we're going to subtract 7 from both sides. These cancel, I get nothing, I get 0. And 9 minus 7 is 2. And our last step is going to be to isolate the variable. This is 2 times x. So I will get rid of that by dividing. 2 divided by 2 is 1. So again, there's an invisible 1 in front of my x. That means it's isolated, it's by itself. You only want to solve for 1x. And I need to divide by 2 on this side. Again, I get 1. So we end up with the answer of x equals 1. Again, how to check that. Step 6, if you wanted to add it to your notes, plug it back in and check. So it's 1, so 4 times 1 is 4, plus 7, that's 11, minus 6 times 1, that's just 6, so 11 minus 6 is what, 5? So on this side we have 5 minus 4x, that's 4 times 1, so 5 minus 4 is 1, plus 4 is, we're back to 5. So it worked. 5 on this side equals 5 on this side. And again, that's solving equations when variables are on both sides of the equation with our 5 to 6 steps.